This is a short demo of Coopr. Coopr is cluster management software that provisions, manages, and scales clusters on public clouds and private clouds. Clusters created with Coopr utilize templates of any hardware or software stack, from simple standalone LAMP stack servers and traditional application servers like JBoss, to full Apache Hadoop clusters comprised of thousands of nodes. So, let's get started. First, we're going to show you how to create a cluster. Let's log in as a user. Today we're going to make a 3-node Hadoop cluster. The first thing you do is click on Create at the top right of the screen. Next, you choose a template from the list. In this case, it will be the Hadoop distributed template. You pick a name for your cluster, enter the number of machines, and click Create. This takes you back to the cluster overview page where you can check the progress of your cluster. We can see that ours is 6% done. Next, we're going to log in as the admin to show you what's in the template and describe what's happening behind the scenes. As an admin, the first thing you see is the overview page with some statistics about clusters and nodes in the system. The admin can also see all clusters for all users in its tenant. Here is the cluster we just created based on the Hadoop distributed template. To examine this template, we navigate to the Catalog tab on the top left. This displays a list of all templates where we can find and examine the Hadoop distributed one. A template consists of 4 sections. The first is the general section where you enter the name, a brief description, and optionally, a lease duration. The lease duration allows you to auto-delete a cluster after a period of time. Next is the compatibility section. Here, we add all the services that can be placed on a cluster using this template. In this case, we have included services like the name node, data node, resource manager, and node manager. These are some of the services required to create a Hadoop cluster. We also specify the hardware types and image types compatible with the template. Next is the Defaults tab. These are default cluster settings that can be overwritten by the user when creating a cluster. In this template, cluster nodes will be provisioned using the Amazon provider with large-sized hardware and the Ubuntu OS. The config field consists of all the config settings for the services on the cluster. And down here we list out the default services that will be placed on the clusters using this template. The last section is the Constraints tab. This tab allows the admin to set rules that determine the layout of the cluster. There are 4 types of constraints. The first type defines a minimum and maximum number of nodes for the cluster. The second type defines which services must coexist on a cluster node. In this template, the data node, node manager, and region server services must always coexist. These are the Hadoop slave services. The third type of constraint defines which services can't coexist on a cluster node. In this template, the name node can't coexist with the data node. This is just saying that master nodes must be separate from slave nodes. The last type of constraint defines limits on the number of nodes that can exist with a particular service. In this template, there must be at least 2 data nodes, but not more than 50. There must also be exactly 1 name node. When a user creates a cluster, Coopr solves for a layout that satisfies all these constraints. Let's quickly check on the progress of the cluster we created earlier. As you can see, it's about 40% done. While we're waiting for the cluster to finish, let's take a look at the top bar where there are additional entities set up by the administrator. Providers are systems like AWS, Google Compute Engine, and OpenStack that can provision machines for a cluster. On the Providers page, the admin configures settings and credentials to be used by a provider. The next page is for hardware types. This is where admins explicitly manage the hardware configurations available to users and how the configurations are specified for each provider. Similarly, on the Image Types page, admins explicitly manage the images available to users and how the images are specified for each provider. Finally, the Services page shows all the services that can be used in the templates. Let's take a look at the Apache service as an example. When defining a service, the admin specifies what other services it depends on, a name, a description, and details regarding how the service should be installed, configured, started, and stopped. With that, let's check again on the progress of our cluster. It looks like the cluster is almost done. Further down on this page, we can see cluster details. There are two types of nodes in this cluster. The bottom one is the master node, which contains the name node, HBase master, and resource manager. Here we can find information about the node, such as its IP address. We can also see a history of all actions performed on a node. For example, we can see that the name node has already been started. Using the IP address of the node or the host name, we should be able to access the name node's UI. So let's try to bring it up. From this UI, we can see that HDFS is up and running, and that there are two data nodes. And now when we look back at our cluster, we can see that creation has completed. This means that all the other Hadoop services like the HBase master should be up. So let's pull up the HBase UI. From this UI, we can see that HBase is running with two region servers. So now at this point, we have finished creating a fully operational Hadoop cluster from scratch. We hope you have enjoyed this short demo. Check out the Coopr product page on cask.co for more information,